Hello students, now we will continue our exercise, that is exercise 7.2. This is the exercise of standard 10 chapter number 7 coordinate geometry. So let us study the question number 8. And what is the question? Question here is that if A and B are minus 2 and 2 minus 4 respectively, find the coordinates of P such that AP is equals to 3 upon 7 AB and P lies on the line segment AB. So here we have given that P is on the line segment AB, coordinate of A is minus 2 and B is 2 minus 4. We have to find out the coordinate of point P. Let's suppose its coordinate is x7, xy. Here we do not have directly given the ratio of M1 and M2, that is AP to PB. Here we have what given? AP is equals to 3 upon 7 AB. So when we take this AB to the left hand side, it will divide the AP. AP upon AB is 3 is to 7. But when we want to use the section formula, we must have AP to PB ratio. But this ratio is what? AP to AB total. So here first of all we have to find out the ratio AP to PB. So how we can find out? See, here we can write down AP is we have to find out the PB. So we can write down PB is equals to, this portion is what? AB total minus AP. Right? PB means what? AB minus AP. Now AP is what? 3 upon 7 AB. So put down the value of AP. So we get PB is equals to AB means AB is as it is, and AP in place of AB we can write down 3 upon 7 AB. Right? And therefore when we take the 7 as the LCM, we get PB is equals to 7 is the LCM. We get 7 AB minus 3AB. Right? And that is what we get. PB is equals to 4AB upon 7. Okay. So now from this we have now AP and PB, both the value we have. So we want to find out the ratio, then what we can do here is we can take it as AP upon PB, that is equals to AP is 3 upon 7 AB upon 4 upon 7 AB. Now AB will cancel out each other, 7 will cancel out each other. What we get here is 3 upon 7. So that now we can say that this ratio AP to PB is now we have, that is 3 is to 7. Now we can, 3 is to 4. So this ratio is 3, this is 4. So we can write down now M1 is to M2 is equals to 3 is to 4. So see, directly we do not have given the ratio. We have to find out the ratio. So do not make mistake here. Do not take this 3 as a M1 and this 7 as a M2. Right? First of all, observe what we have given, then only apply the formula. Now we can apply the formula to find out the P of xy, that is the section formula. So we can write down P of xy is equals to M2 into x1. M2 is 4, x1 is minus 2 plus M1 into x2. x2 is 2 upon M1 plus M2, that is 3 plus 4. Now for the y coordinate, M2 into y1. y1 is also minus 2 plus M1 into y2. y2 is minus 4 upon M1 plus M2, 3 plus 4. So now it will be easy to calculate. Okay. Now here we get minus 8 plus 6 upon 7. And here we get minus 8 minus 4 3s are 12 upon 7. So we get P of xy is equals to minus 8 plus 6, that is minus 2 upon 7, and here 12 8, that is minus 20 upon 7. So this is the point P with whatever we want to find out. Okay, now let us study the question number 9. And what is the question? Question here is, find the coordinates of the points which divide the line segment joining A minus 2 2 and B 2 8 into 4 equal parts. Here we have to divide the line segment AB into 4 equal parts. So remember, before this we have find out the coordinates of the points which divide the line segment into 3 equal parts. So when we have to find out their 3 equal parts, 2 points are there in between AB. Here 3 points. Here are 3 points are there in between line segment AB. So that AP will be the first portion, PQ will be the second, third, and fourth. So 4 equal parts are there. So how many points we get? 1, 2, 3, and 1, 2, and 3. Now what is the? Now we know that all the portions are equal, right? So this portion is what? 1/4. This is 1/4. This is 1/4, and this is 1/4. But here we have to use the formula that we have already studied. What that formula? Here you can see that Q is the midpoint of A and B. Q is the midpoint of AB, right? So here we can directly use the special case of the section formula, that is the midpoint formula. Let's suppose Q has the coordinate x, y. So we can find out the Q. How we can find out? By adding x1 x2, that is minus 2 plus 2 upon 2, and y1 y2, that is 2 plus 8 upon 2. So here we get 2 minus 2 is 0, 8 plus 2 is 10, and 10 by 2 is 5. So here we get the coordinate of the x, coordinate of the point Q, and that is 0, 5. Now think about, P is the midpoint of AQ, yes, and R is the midpoint of QB. So to find out P and R, we also have to use this formula, right? So in this way, this sum will be easy to calculate. So now we can write down P is the midpoint of AQ, right? So now we have to consider this point and this point, A and Q, right? So again, suppose P has a coordinate xy, so we can write down the formula, midpoint formula, minus 2 plus 0 upon 2, because x1 y1 is this now and x2 y2 is this. So this is the x coordinate, y1 plus y2, that is 2 plus 5 upon 2. 2 plus 5 upon 2. That is why here we get this is minus 2 upon 2, that is minus 1. 5 plus 2 is 7. 7 upon 2. This is the point, coordinate of the point P. Now here also R. R is what? R is again the midpoint of QB. So R is the midpoint of QB. Okay, so now here we have to apply this formula for Q and B, right? So we can write down, let's suppose its coordinates are xy, that is equals to 0 plus 2 upon 2 and 5 plus 8 upon 2, right? So 0 plus 2 is 2 and 2 upon 2 is 1. 8 plus 5 is 13, 13 upon 2. So this is the coordinate of the point R xy. So see how this process will be easy to calculate the points which divides the given line segment into 4 equal parts using the special case of section formula. That is, we can say the midpoint formula. So this is the coordinate of the point Q05. This is the coordinate of point P -1 7 by 2 and coordinate of R 1 13 upon 2. Right? So this is all about how we can solve this type of questions. This is all about this lecture. Thank you.